Okay, hello everyone, and a big welcome to our POSPac Assure webinar today. We launched POSPac Assure 1 year ago and have redesigned the user interface since then to create an intuitive workflow, making the web application far more attractive than it was. So today we're showing you how easy it is to master quality control, calibration, and SBET generation of GNSS-INS data with POSPac Assure. I'm Nico Jaeger, Applanix POSPac Product Manager, desktop as well as cloud variant, and I'm delighted to be joined by Nick from our pre-sales support team and Jason from our marketing department. Should you be looking for more great content, please check out on our past webinars in our webinar center. Just search for a webinar on our applanix.trimble.com site. Okay, some logistics words before we start. The presentation will take approximately 30 minutes. Then we'll switch over to a live demo, approximately 15 or 20 minutes, and then we will have some time for the Q&A session. The webinar will be recorded and shared with you. All attendees are muted. Should you have any questions, there is a Q&A box at the bottom where you can enter your questions and we will attempt to answer them during the Q&A session, basically after the presentation and the live demo. Or if we don't have sufficient time, we will get back to you in an email. Okay, so what's the agenda for today? We'll talk about what is POSPac Assure. We'll speak about the input, deliveries, and features that we serve, the variant processing modes that are available, the business model, so basically the supported plans. We'll touch a little bit report analysis. So what are you going to do with the reports that you're getting back? Then some additional features, go on to the summary, and then we'll start the live demo, and at the end, the Q&A session. Okay, so what is POSPac Assure actually? So this is a user-friendly web application to generate GNSS-INS real-time quality reports, calibration estimates, and a trajectory, which is our famous SBET file, the GNSS-INS trajectory. And we are leveraging our POSPac Cloud engine in the backend. So this one shall assist integrators rapidly with a high level of automation and precision. And we're supporting basically all GNSS-INS land and marine products, including real-time systems such as the BD992-INS or the BX992-ER or the RT fleet such as the RT200, in addition to our advanced air mobility system called PX1. However, for all of those different products, we are not supporting all different features. So for instance, the real-time products, we only support the features real-time QC and calibration mode. You will see in a couple of minutes what that means. And for the PX1 system, so this advanced air mobility system, it is the real-time QC mode only. So who's the target group? Who do we want to get on this one here is customers who need a simple tool to verify their GNSS-INS integration, and customers who need an easy tool to verify their platform real-time performance. And of course, customers who require a precise GNSS-INS trajectory, which is, again, the famous SBET file, smooth best estimate of trajectory. And eventually also customers who don't want to install, learn, and use our POSPac Complete desktop software. One word of caution, obviously here, customers or users who want to streamline and automate a production environment shall obviously rather use our tight POSPac Cloud API integration. And I'll get to some words about that later on. So here are the three main features that we support with POSPac Assure. So on the left side, you can see the real-time QC feature. This is a rapid real-time performance check that you can do. And all of this information is summarized in a single PDF report. So think about you collected GNSS-INS data in real time, and you want to have a smart tool that advises you on how well the performance was. You can just load that into POSPac Assure, and you get a tailored PDF report back with a bunch of plots, such as what the RMS values are for position orientation, what was the satellite coverage, what was the signal to noise ratio, what was the acceleration on the system, et cetera, et cetera. That's all stuffed into this PDF report. The second feature, we call it calibration mode. That allows to calibrate parameters of your components, such as the lever arms that we deal with. For instance, the lever arm to the GNSS antenna, or the lever arm to the DMI for the land applications, or the vector between two antennas, which we call GAMS, etc. So you can basically use POSPac Assure to calibrate your GNSS-INS integration. And same here, you would get back a single PDF report with a table of all information that you require and a bunch of plots to analyze your results. That's, again, a tailored report that is a little different than the ones for the real-time QC. And eventually, we also serve the ground truth part. Ground truth means that you can post-process the GNSS-INS trajectory through POSPac Assure to generate an SBET file. So in addition to, well, again, a ground truth PDF report that's tailored for that purpose, you would also get back your SBET file. So position orientation in the frequency of 5 milliseconds to 200 hertz. So with this one said, I'd like to question you now, so we can start with a poll and like to get your feedback on the following question.
Hi, so Nick here. I'll read out the poll for those interested. It'd be great to get your feedback. So question one, which POSPac Assure feature are you most interested in running? Nico's obviously given you a brief overview of what's available. So from an immediate first impression, what do you think is going to serve you best? Where do you see the most value? We'll leave this open for 30 seconds or so get your answers in, and we'll see what we can learn from it.
Yeah, thank you very much, Nick. So let's wait a couple of seconds and then we proceed. All right, thank you very much for your help on this one. Let's proceed with the next slide. So in terms of the workflow, I can only convey the message. It is simple, simple, simple. So what you've got to do is create an account, log in to this web application, then drag and drop your rover file, which is a T04 file or our legacy POS files. And optionally, you can also load your own base file if you need to. Otherwise, there are mechanisms to download base station data automatically or use our PPRTX service, etc. So you select the feature that you want to choose, so real-time QC, calibration mode, or ground truth, and select the post-processing mode, and then submit the project. In terms of the user interface, as I said, this is very easy, and this is also what we had redesigned over the last 12 months. So again, you will drag and drop your rover files into the map. The trajectory is going to be overlaid over the map. You will then select the feature that you want to leverage here, and eventually the POSPac Assure tool is also smart enough to even make a suggestion of what is the best post-processing mode, depending on where you are, depending on what type of data you load. It will have a suggestion between the different processing modes that are available. You can also use the so-called Trimble Center Point RTX function to survey in base station coordinates. So if you bring your own base station and you have an uncertainty about the coordinates, you can leverage that function from inside of this app. You have also an overview of the project history, status information of it, and you would always have also access to the plans that you signed up for. So what are the benefits of POSPac Assure? Again, it's an easy-to-use web application with a very modern UX UI for intuitive workflow that generates very fast deliveries. You would not need to install POSPac desktop software locally. You don't need to learn POSPac complete desktop software. And the POSPac Assure business model has basically two main options. Either you sign up on a monthly subscription with the so-called add-on tokens. I will explain that a little later. Or you can also proceed and pay permission. So you just only pay permission that you process and you don't sign up on a subscription basis. Of course, like for every other application that runs in the cloud, we will take care about software updates, about security. Of course, there's no license handling, no local license handling. There's nothing that shifts around. It's a very easy thing, and it's connected to a very redundant cloud infrastructure. So let's get to input, deliveries, and features. So what's mandatory in terms of input file is always the rover data. So that might be the T04 file or our POS files. And optionally, you can also upload your own base station. But as I said before, there's also options where we take care about this one. We can automatically download base stations for single base processing. We can leverage smart base processing where multiple stations are downloaded. And of course, we can also leverage the Trimble RTX center point technology here, which we call PPRTX. Now, in terms of the deliveries, you would always get back a zip file with some files embedded. In terms of the real-time QC feature, that will be mainly the PDF report, but there are also some side products included, such as the KML or KMZ file, the real-time navigation solution, the vehicle navigation solution, and some other log files. When it comes to the calibration mode, same content here, just the PDF report obviously looks a little bit different because you're calibrating something, but the content is basically the same from the zip file. And finally, in terms of the ground truth, of course, another PDF report, a different one that, for instance, also shows the difference between the real-time solution versus the post-process solution, some side products as like the KML, KMZ, etc. And then most important for ground truth part is you would get the smooth best estimate of trajectory, the binary file format, but also an ASCII file that represents your trajectory, so position orientation with a frequency of 200 hertz. So let's dive a little bit deeper into these two main features, calibration mode and ground truth. So for the calibration mode, this one actually uses all the values from the real-time setup of the system, such as the GNSS lever arm, IMU lever arm, for land products, the DMI lever arm and scale factor, and also the rotation between the inertial measurement unit and the vehicle frame, the reference frame. So there's no parameter setup in this POSPac Assure web application. That needs to be done on the system before. And this is what we leverage here, POSPac Assure. We'll then float all of these lever arms and calibrate them. So after this process, you'll get back a PDF with the new calibrated values, and you would bring them to the hardware and make the settings there and continue with next missions. In terms of ground truth, in this context, same here, all the lever arms and all those parameters need to be set up properly on the system, in order to allow the creation of the unbiased and precise GNSS-INS trajectory, again, this SBET file. So in this sense, we are using all the values from the real-time setup. So all the lever arms, all the rotations, the scale factors, etc. And the assumption is that this one is correct. We'll keep it fixed so that you get really an unbiased trajectory. Now let's get to the processing modes that we support. So first of all, the most exciting processing mode is our PPRTX, stands for post-processed RTX. That one uses a worldwide cloud correction service from Trimble, where you don't need any base stations. And it gives you a solution with a centimeter level of accuracy. Then we also support single base processing with two options here, either the auto download, where we leverage our own database of more than 10,000 base stations worldwide, which, by the way, you can also check in our so-called TGAP app, which is free of charge, or single base processing mode, where you as the user provide the base station data. This is a very traditional approach. So the baseline should be within 20 kilometers to get the most or the best solution out of it. But also if your rover data contain already RTK data, so basically you have a reference already, correction service reference, that one can also be post-processed through POSPac Assure. And then the approach that we call Smart Base, same here, we automatically download base stations that are available from our database. And it creates a network of stations around your mission area. And we kind of apply like a VRS concept in the back end. But with a good point that this one has also a single base fallback. So in case of this network, it's not strong, it's a weak network, or it's not trustworthy, whatever, then there's a fallback mechanism where it will then leverage single base processing. So one more word about PPRTX. So this service is obviously very okay in open sky terrain or moderate GNSS environments, but not very ideal for processing modes in GNSS critical or denied terrain. So it is obviously recommended to collect data always in open sky when you do the calibration of the data. And in addition to the processing modes that I just mentioned, there is also an autonomous processing mode where POSPac Assure automatically detects what type of corrections were collected in real time. We will use them in the post-processing mode. So in terms of the SBET export frames, that one really depends on the processing mode and the base station coordinate source selection here. So for instance, if you process in PPRTX mode, or if you process in smart base mode, or if you process in single base mode, but you leverage the RTX functionality to survey in the coordinates, the reference frame of the trajectory result will be in the latest international terrestrial reference frame, which is the ITRF 2020, at the original epoch of realization, which is 2015, so January 1st, 2015. However, if you, for instance, bring your own base station coordinates, your own base station with your entered coordinates, or you trust the coordinates from the RINEX file that you uploaded to the service, the solution will be tied to the coordinates of that base station. And the same applies obviously to the RTK. So if there was any real-time kinematic correction data included already in the rover data, then the final solution will be tied to those coordinates. Some more words about the Trimble RTX concept. So Trimble has a network of GNSS tracking stations worldwide. I think it's more than 100, collecting data day and night, and all data are processed in a control center. And via a smart algorithm, it creates a set of correction data for the rover. It corrects for the standard GNSS error budget, such as for satellite orbits, clock errors, atmospheric errors, etc., and make those corrections available in real time as well as in post-processing mode. So that service was introduced by Trimble, I think it's 2011. But what means PPRTX in this context? So PPRTX stands for post-processed RTX. So this is a cloud-based global GNSS correction service that basically utilizes the Trimble RTX technology to provide centimeter-level post-processed positioning without the requirement of any base station. And those corrections are available within minutes after mission completion. And that makes it a very powerful alternative processing mode to single base or the smart base concept. Again, PPRTX is very perfect for open sky or moderate open sky terrain. It's not really perfect for multi-path environments and urban environments, but really depends on what performance you want to achieve at the end. So the Trimble Centerpoint RTX services are split into two regions. We do have the FAST region, which is in Central Europe, North America, and some selected regions in Brazil. And we have the rest of the world, which we call global region. The global region corrections are based on a global ionospheric model, while the FAST region uses a denser network of reference stations to compute a regional ionospheric model for atmospheric corrections. Anyway, the post-processed RTX in general is covered globally. You just have a little quicker convergence time in the FAST region, about 1 to 2 minutes for all the satellite constellations. Still, very fast convergence time is available in the global region. It's below 3 minutes. You can see there's not a big difference, right? Specifically, if you leverage the latest thickness of the GNSS navigation systems. And to be more specific here, the Baidu 3 generation is very helpful. At the end, the accuracy is identical worldwide, given that the solution has converged. So what are the supported plans? What is basically the business model here? So first of all, everyone who signs up on it has a free trial. And that free trial includes 3 tokens. A token translates into a mission and grants 1 mission load into POSPac Assure, independent of the mission length. So 1 mission is 1 log of a consecutive GNSS-INS data without any data gaps. So again, everyone who signs up has that free tokens. And from there, the user can decide whether he wants to go with a subscription mode. And here are the subscription modes that we support. So first of all, the base mode. And the base mode features real-time QC and calibration. It includes 10 tokens on a monthly basis. Reprocessing of a mission is free of charge, and you can upgrade anytime to your professional plan. The professional plan features real-time QC calibration and ground truth. So with a professional plan, you can generate an SBET file. Same here, you have 10 tokens included. Reprocessing is free of charge, and you can downgrade to a base plan if needed. Should the 10 tokens not be sufficient over a period of 1 month, you can purchase add-on plans. So each package contains another set of 10 tokens, and we apply a discount. So multiple tiers are considered and discounted up to 25%. The tokens from the add-on plans are valid for 12 months. And that brings me to the pay per mission method. So that's the second plan, the second business model that can be applied. So pay per mission means you just upload a single mission, you process. If you are happy with it, you press download, and then you pay for it. You can process multiple times. You're going to be charged only at the time when you download the solution. So if you're happy with the solution, you can download and then you would pay. Same here, there's two different modes here, which is the base, which features real-time QC and calibration mode, and the professional one, a little higher price, features also ground truth, where you can generate an SBET file. And that brings us to the second question for you today. Please get that into the, thank you very much. And Nick, please proceed.
Okay. Yeah, question number 2. Business model preference. There's obviously two clear modes here: the subscription with the add-on options and pay permission. For everyone looking at the questions coming in, which we'll get to, there's a good field of experts on the call, which is great to see. And I'm hoping there's a lot of new users considering post-processing. So which one of these methods of payment do you think you're going to subscribe to? Pay permission, the cost of a coffee to QC your data. What's more important? Maybe they go hand in hand. And subscription. If you see some solid use out of this on a monthly basis, I guess the main thing here is you have the flexibility. So we'll leave it open a few more seconds, get your answers in. Be interesting to see where people's preference lie.
Thank you very much, Nick. All right, let's proceed. Thank you again. That brings me to section number 5, report and analysis. Just a few examples here. We don't dive too much into those details. Here is an example of the report that is generated if you use the calibration mode. For instance, here on top, you can see basically the completeness of the components that are that have been loaded into POSPac Assure. So it checks whether GNSS complete, DMI is complete, IMU data, GAMS data are complete. So you have this traffic light principle here. Everything is basically bundled in one table. And then if you look further down, you can see that the lever arms are displayed, the original lever arm, as well as the green highlighted calibrated lever arm. So you can see immediately if there was a difference, and you would bring that obviously back to the system and make the changes if applicable. So we have the GNSS lever arm, DMI lever arm, scale factor, GAMS lever arm, and at the bottom, more for the autonomy industry, is the bore set heading between the vehicle and inertial measurement system. Another example of a plot that is part of the report is the GNSS QC statistics. So that gives you an insight of how well the GNSS processing went. It will display all of the satellites that were tracked and used for post-processing purposes. And it gives you also an insight of the ambiguity resolution. So you may know if you have a fixed ambiguity solution, then this is the best that you can achieve, centimeter level accuracy. Some epochs might be in float solution, where you have very challenging GNSS environments. And eventually you may have also epochs there where you have no solution. Think about you are below a bridge or in a tunnel. In which cases the system operates in that reckoning mode. However, in normal situation, you would expect something high percentage in fixed mode and less in float and no solution, and that gives you already a good understanding of how well the processing succeeded. In other plots here, so of course we will report the RMS values, so the estimation of the position accuracy and the heading accuracy. Of course, we have also roll and pitch accuracy. This is just an example here. Position is displayed for all 3 axes, north, east, down. Then what we also have is the bore sight angle between the vehicle and the inertial measurement system. That is most relevant really for the autonomous industry, for instance, less important for the mapping industry. And another example here about the total acceleration plot, that could be very helpful to detect vibration. So the total acceleration helps to identify platform integration issues, for instance. So typically the total acceleration is between 0 to 0.5 g, which is normal. However, if the overall plot leads more towards 1 g or appears biased, or if there are too many peaks over 1 g, for instance, it could indicate a vibration issue. on your platform and on your integration. So excessive platform vibration means that the platform's true motion may not be sensed. And therefore, the GNSS-INS solution becomes decoupled from the reality. That's something that you obviously want to avoid. High vibration should be damped. So if you want to learn more about those details, I encourage you to also open up the tutorial in the web application. Everything is very well explained there, and you can read through that. Okay, that brings me to section number 6, which is some additional features. One thing that I had mentioned already is think about you bring your own base station, and you have no idea about the coordinates of that base station because you didn't pitch it over a known point, or you got the base file from somewhere, certain provider, but you don't trust the coordinates or you don't know better. We have that RTX survey-in functionality embedded in POSPac Assure. So you can select how to base position using RTX, and it will automatically survey in the coordinates. That will provide you precise coordinates of your base station, and it will also remove any datum shift concerns. Datum shift concerns can obviously appear if you have a base station from a certain provider, but you have no idea in what frame the coordinates are provided, right? And that can always lead to a datum shift problem in your final trajectory. Now, this is static RTX processing, and it's also available minutes after data collection, same as the kinematic PPRTX processing. What we support here is the Trimble native file formats T02, T04, and then also Rhinex file formats version 2 and 3. And another side note about our Trimble GNSS Augmentation Planner. So this is a free of charge web application which visualizes all of the Trimble correction services that we support worldwide. So we have support of more than 30,000 reference stations from 40 networks in 160 plus countries. And it's a very easy tool. You just draw your area of interest, or you load a T02 file, T04 file, sorry, POS file, Rhinex file, KML shape file, anything that describes basically your trajectory or your mission area. You load that into the TGAP app, and it will report back what correction data are available. And it will also make a suggestion of what is a good processing mode. By the way, that suggestion of the processing mode is incorporated into POSPac Assure. So it's already kind of there. But this tool gives you another web application where you can visualize your mission, your trajectory versus correction data that are available. Okay, and then of course, for let's say a tight integration for fleet volume processing, for OEMs, for anything that requires high volume processing, we do also have the POSPac Cloud API integration available. So we have that API, and for POSPac Cloud, we have a staging environment for onboarding purposes, testing purposes, and then we have the production environment, obviously. This is a very redundant system. We just recently reached a so-called zero downtime scenario where whenever there's maintenance ongoing, whenever there's patching, etc., there's no downtime for the user. It's always running, basically. And same as for the web application, for the business model, we support a pay-per-use concept as well as a subscription concept. So if you have questions about, just reach out to our sales team, customer support team, or even to myself. We can help you on this tighter integration of POSPac Cloud anytime. So that brings me to the summary, and then we go over to the demo session. So POSPac Assure is an easy-to-use web application mastering GNSS-INS quality control, calibration, and aspect generation. And it's all powered by the POSPac Cloud engine. So there's no software installation or any complex licensing required. All right, with this one, I'll hand over now and stop sharing my screen, hand over to Nick, who will run a little demo session for you guys.
Thank you, Nico. Right, let me get my screen organized here. May the demo gods be with me. Here we go. Nico, can you just confirm you can see that okay before I crack on?
I can see the live demo slide, if that's what you wanted to show.
Yeah, perfect. So what I want to do here is I've got a bit of a case study to guide you through. We'll look at the real-time QC and the ground truth results. You can see how they tie together nicely. And of course, we'll look at the calibration mode, because if your system's not set up correctly, then it doesn't matter what you collect, you will have problems fundamentally with your deliverables. So, POSPac Assure. When you've signed up with your Trimble identity, you've gone to the POSPac Assure link. This will be the landing page you're presented with. Initial impression, you might think there's not a lot here. That's exactly the point, right? As Nico said, it's simple. We have our main processing modes across the top bar, our real-time QC, calibration, and ground truth. You have a map area to drag and drop your 000 or your T04 data into. And if you've been in before, you'll have a list of your recent projects. Before we dive in, I want to just bring your attention to the account menu. Gives you an overview of your tokens available and gives you the options to subscribe should you be running out of tokens. As Nico said, everyone has access to 3 free tokens. So I urge everyone on this call just to go and take advantage of it. 3 free processing rounds. Even if your data is good, you will stand to gain some improvement by creating an SBET and applying it. Maybe you've got a problematic data set that you just haven't been able to solve. We're doing it for free here. Take advantage. So if you take your said data, the concept's easy. Real-time QC, we're going to start with that. There's a little tooltip here just to give you an idea of what to expect when you run this mode. As we've discussed, it's going to return a PDF report with plots describing the metrics associated with your real-time navigation. Now I have a 000 file here that I'm just going to drag and drop. That's step 1. You can wait for the trajectory to load so you can geolocate yourself. Maybe you're not the surveyor that completed the job and you're someone in the office carrying out this task. You don't have to do this. You don't have to wait. You can go straight ahead and click submit project. That'll send the data up to the cloud. It'll run the extraction. You'll get an email pop up saying your data's ready. It'll take you back into POSPac Assure and you can download your report. To show you what the next stage of that looks like, we have a trajectory loaded here. The project name is auto-filled out by the file name, just to try and make this as smooth as possible. If you want to edit this to something else that is more representative of what you're trying to do, by all means, edit it. Not a problem to do that. Now, I want you to note here the environment. It's a trajectory. It's clearly an MV system, a POS MV system, typically for marine use, but there's a lot of inland water surveys to be done. And this is a river in the UK, and you can see already we're passing under a bridge. There's an urban environment, there's trees, lots of things to really affect our GNSS data. But unless you've been looking at this in real time, you really don't have any idea the effect that's had. So by submitting the project, you're going to get an idea in PDF form. So just to reiterate, step 1, click the mode you want to do. Step 2, load your data in. Step 3, submit the project. That's getting sent up. You can then open another POSPac Assure, do another project, open another one, do another. You can run these sequentially as many instances as you like. Everything's going up into the cloud. There's no license restriction here. Of course, you will use your tokens every time you submit and download something, but this sequential workflow, being able to run multiple instances, can save you so much time. I've used this myself in a support instance of trying just to QC multiple files at the same time. It's just a real simple, easy way to do it, and I can go away and do something else. What you end up with, we've already looked at a few of the components of these of the real-time QC report, and the first page may just be give you all the information that you need. You get your project name, the task you're carrying out. You get your mission date and your duration. Again, maybe you're not the person that that carried out this job. So this simple sort of metadata is included. You get some information of the hardware. This is a POSNV, as I say, a WaveMaster 220 system. But perhaps what is more important is this real-time QC summary, as we've got highlighted in the red box here, is our real-time RMS of our northeastern down. And you can see that's decimeter level. Straight away, whether you're land or air, decimeter level precision is generally not good enough. So this tells us that we need to do something. There's some problem to be solved. Further from this, you have the data check. And you can see GNSS, IMU, DMI, and GAMS. 3 out of 4 are complete with valid data. This is a marine system, so DMI isn't applicable. That's why it's missing. Nothing untoward going on here. If you want to dig in a little further, we can look at our real-time RMS values. These relate to those values in the table. An average doesn't always give the full story. So this gives you a plot over the time of the survey, and you can clearly see the RMS busts. And this is expected. You know, we're under a bridge. We're really in a harsh GNSS environment here. So these busts, even with a WaveMaster system, is to be expected. And we can reinforce this by looking at other plots like our GNSS satellite lock and elevation. So this plot describes the elevation of the different satellites we're tracking. And all of those red crosses are cycle slips. Now, a cycle slip is every time the link between the satellite and the receiver is broken. That could be caused by many things. In this example, as I hope you're starting to understand, it's because we've gone under a bridge. But if this was in an open sky environment, middle of the North Sea or on a motorway, if you see lots of cycle slips, then you have to question why that is. Are we starting to see a GNSS cable failing, an antenna failing? So not only can you use it to give an idea of the environment, but it's there as a check for your hardware as well, adding this extra value from a simple PDF report. Now, the point I really want to get to here is what bad real-time data looks like. So I've got a slide here. What we see here is a multi-beam survey carried out in this river example that we just did a real-time QC run on. We know the RMS is bad. We know there's some GNSS issues. And what this does is really drive the point home. This is what you would see on your screen as a surveyor collecting the data. This is perhaps what a client is seeing. I'd hope not, but we have the option to change it. What you see is a grid here of uncertainty in the z-axis. Think of uncertainty as a standard deviation. This is colored by 0 to 20 centimeters. And in here, there's lots of overlapping lines. So when these overlapping lines do not meet within this 20 centimeter range, you get this red oversaturated color. And as you perhaps expect, around these bridge footings, these sort of pentagonal shapes, there's a lot of high uncertainty. We're losing corrections, we're losing GNSS. It's expected to have this. When you run a cross section across these bridge footings, we see this deviation of overlapping lines. If you're in a safety of navigation or an engineering sort of job, we have no idea where the true surface is here. It's very evidently not good enough for purpose. We can't submit this to anyone. So how do we fix it? We go back to our POSPac Assure. We load in our data and we want a ground truth. Ground truth is this SBET production. And that's really what we want to focus on here. Same process as before, you drag your data in, choose an appropriate project name. It suggests PPRTX as a default processing mode. As Nico alluded to, PPRTX is the simplest way to process your data. All you do is click a button and POSPac in the cloud handles the rest. PPRTX will give you centimeter level data anywhere in the world. I've got data 76 north in Greenland to 65 south, just north of the Antarctic, all using RTX, all getting centimeter level data. However, in this case, we want to use single base, as we alluded to. PPRTX is great in open sky environment, and it's getting better in difficult GNSS environments, but sometimes you just can't beat the traditional methods. When we look at our real-time data, we've seen we've had RTK outages, we've seen we've had GNSS issues. The most precise, robust way to solve those is with a single base solution. Now it's all about preparation. This survey company, Ultrabeam, who kindly provided this data, they're based down in the southwest of the UK, had a base station set up just 300 meters away. and they logged that static data as well as sending the real-time corrections via radio to the unit. Now, by simply using the static data, we remove the telemetry aspect. A good deal of these high uncertainty values we saw in that bathy data are due to RTK dropping out. So we can remove that straight away by using the static data. And we're prompted to upload a base station. Now I have the static file here, so I'm simply going to drag and drop it. Now, I do not know what the coordinate system was in this base station, but I know it was surveyed in with precision. So we're going to use the coordinates from the base station file. As I said, if we had no knowledge of this, you can use RTX to make those precise. But I'm going to trust my customer. I think this is probably a pretty good base station setup. So we're going to use the coordinates in the file and whatever datum they were coordinated in. In the UK, typically it's going to be ETRS 89. If those coordinates are processed elsewhere, you have the option to enter a manual base position, should you wish to override any of these other settings. But we're going to use the coordinates in the file. We'll stick to our IMU mode of auto. POSPac will assure we'll pick the right mode in that respect. And then we submit the project. It's as simple as that. So to recap, you go into ground truth, you're loading in your data, you're selecting your processing mode, and you're pressing submit project. That is a minimal number of steps to get to SBET production. I'll go ahead and click. As I said before, project's getting submitted, goes up to the cloud, it'll email you with the results, and you can go into your project to download. But again, what we're really concerned about is the effect this SBET has. That's where the value is. So PDF report, again, similar story to the real-time QC, but straight away, we can see our SBET trajectory has a much better RMS values. Previously, we were at the decimeter level, 15, 18, 30 centimeters. We've brought that down to sub 3 centimeters. So we've solved some problems here. We've really improved the RMS of our solution. So we know when we take this SBET and we apply it to our data, we're going to see some improvement. To dig into that a little further, we can look at the navdiff, this difference between our real-time and our SBET. And that plot might look familiar. It looks an awfully lot like the RMS plot that we saw in our real-time QC report. And what we're seeing is the difference between the two. The fact that there's these big spikes as a difference means we're solving for them. And we can look at the RMS values for our smooth best estimate trajectory, and we can see everything is sub 3 centimeters, more or less. And that ties in with what we saw at the table. But looking at graphs is great, but it doesn't give us the full picture. This isn't what the client's interested in. They want to see confidence in data. They want to see a solid surface that is representative of the truth, of the ground truth, if you will. So to complete this story, I've taken the SBET and I've applied it in my third-party post-processing software to my multi-beam sounding data. And I think the evidence is clear straight away, right? It's the same color scale. We're still looking at standard deviation in the z-axis, 0 to 20 centimeters. But we've gone from a lot of uncertainty, particularly around that lower bridge footing, to a really sharp, low uncertainty solution. Of course, there's still some red bits in there. This is never going to be absolutely perfect. We are denying ourselves of a lot of GNSS satellites. And this is a river. You could see in that previous picture, that's a pretty turbid river as well. So who knows what the riverbed's doing? I suspect there's a lot of fluid sediment in there. And stuff moves around these bridge footings a lot. But the general picture here is that we have drastically improved the quality of the data. The same cross-section across the bridge footings, all these overlapping lines are now tying in really tightly with one another. And from an engineering or a safety of navigation standpoint, we can be a lot more confident in where our true surface is. And to tie all this together, because I'm a surveyor, I can't talk about this without showing pretty pictures. This is the same data set. The bathymetry data that was colored in uncertainty is now colored by depth, blue being the deepest, red being the shallowest, but it's combined with LiDAR data. This was all collected on the same platform. But what the point of showing you this is, apart from it's a cracking image, is that the SBET, those 3 simple steps in POSPac Assure, is what allow us to do this. You could never align these data sets without that SBET. It just wouldn't look right. And LiDAR is so much more prone to misalignment issues than multi-beam, just simply with the greater ranges involved. So being able to apply your SBET to both your multi-beam and your LiDAR data allows us to create these above and below waterline fully georeferenced images, which you can just extract so much more value out as a client looking into this data for whatever the application is. Now, none of this matters if you have a poorly installed system. So this brings me on to the calibration mode to finish up this part of the demo. I won't go through the drag and drop process again. I think hopefully by now you've gathered that POSPac Assure is dead simple to use. We have our data. This is a land system. It's selected. It's prompting us to use PPRTX. This time we're gonna take its advice, and we're going to submit project. Now, calibration, installation parameters, they're one of the biggest gotchas, whether you're land, air, or marine. It's so easy to get a plus or a minus wrong. There's so many different conventions. Maybe X is forward, maybe X is starboard, which is positive, which is negative. If you spend a very small amount of money and use these 3 simple steps to get a PDF report to validate your offsets, maybe you've moved something, maybe this is a vessel opportunity, a new installation, or you just haven't used it for a while and you want to just get that sanity check that everything is where you think it is, then running this and getting the report back is worth its weight in gold. So similar PDF format, and this calibration mode summary table is all you need. Now, this is a land platform, so there's a few extra pieces here that perhaps marine and airborne may not be familiar with, but the point's the same. GNSS leave run. We have our original coordinates, X, Y, and Z, and our calibrated. And you can see here, everything's within about 2 centimeters. So we can be pretty happy that that's been measured and applied correctly. If we move down to our DMI, this is the classic example, perhaps, of getting the sign wrong. In our x-axis, we can see it's a minus 0.45 and it's calibrated to 0.48. If you take the sign error out, it's within 3 centimeters. So this is just a simple, I got the X direction wrong. It's so common. Doesn't matter how experienced you are, this will happen at some point. But that's exactly why this mode exists. Collecting 15, 20 minutes of data, upload it to POSPac Assure, running those 3 simple steps can give you assurance that your installation parameters are correct. And that underpins the whole workflow of your job and allows you to create those fantastic images that we've seen in those previous slides. And so just, I guess, to wrap up on the POSPac Assure side of it, no more pictures, I'm afraid. But if you come back into your projects, you have the option to not only see your status, the calibration mode still up in the cloud running. The ones that are completed will be flagged as successful, of course. You can come back and download those. They're available for 30 days after the point of processing. You can rerun them. Maybe you want to use a different mode. Maybe you want to rerun it for whatever reason it is. You're not using any more tokens to rerun a survey. So if you need that assurance to go and do it again, then it's not going to cost you any more tokens. I hope that's given you an overview of the 3 main modes and how easy those simple steps are to get to predominantly an SBET. That's where the real value lies in this. But all of that is underpinned by having confidence in your real-time data and assurance that you've applied your installation values correctly in POSView or wherever these values are. And that brings us to the end of the demo side. So I will stop sharing my screen here. And I think we have one final poll. If perhaps, Nico, you want to share yours again.
Yeah, thank you very much. Thank you very much, Nick, for that good presentation. Sorry. So we have another poll before we go to the Q&A session. Yeah. Yep, I'll read that one out. So, I mean, the biggest challenge. Some of you will be familiar with processing data, some not. But what are your worries? What are your concerns? What's the biggest challenge when considering data processing? Is it the price? Complexity, learning curves? Those who've used POSPac before, or any of these other data processing softwares, you've got to know the tricks. You've got to know the workflows.
Installation version control, when you're offsite in the middle of the job, maybe you're in the middle of the North Sea, changing firmware versions, changing software versions in the middle of a job is never appealing. And license management, whether you're a USB license or a soft license, whatever it might be, it's got to be applied in the right way. It can be difficult to manage. So yeah, it'll be interesting to hear your insight. What do you see the biggest challenge being here? And
Yeah, thank you very much. Yeah, sorry, go ahead, Nick.
Yeah, no, I said we'll close that one off now. And unless you've got any final words, Nico, we can move on to the Q&A session. There's a good number of questions in, and we've got about 5 minutes or so to blast through a few of them.
Yeah, that's true. Thank you very much, Nick, again, for that very good demo session. So, yeah, I think we only have 4 or 5 minutes now, unfortunately. But as we said, don't be concerned. All of your questions will be answered. The ones that we don't touch now, we'll get back to you later on and answer. So, yeah, maybe, Nick, you want to go through and pick some, and we'll get them answered for the next 5 minutes.
Yeah, a few people have asked, and this is very marine centric, is the TrueZ output available on POSPac Assure? I'm glad people are asking, because that means you're using it and you're seeing value in it. Yes, is the short answer. TrueZ is available. It's the default SBET that is produced for marine platforms. And I did see someone ask, what is TrueZ? And in short, and that data set was a perfect example of it, is TrueZ is where POSPac Assure combines the heave data with the combined GNSS inertial data to help constrain the height during a mode change. So when you're going under a bridge or you're losing RTK corrections, the heave can aid the system to constrain those high RMS issues. That's the purpose of TrueZ. A couple of people also asked about the ground truth option providing the SM RMSG file. Yes, it does. It comes in the zipped up folder as part of your SBET, so you can apply that in your post-processing software as appropriate. In the calibration mode, is there a way to import updated offsets directly into the sensor, or does the user need to type them in? So this is the point where I guess things diverge. POSPac Assure will give you the values, but they need to be manually typed into POSView or to your appropriate UI to apply the correct values. There isn't a direct link between the software and the hardware in this case. Let me see what else we've got here. Time, we've got a couple more minutes. There's a couple of questions about how POSPac Assure ties in with POSPac Complete. Nico, perhaps you want to take that one.
Can you repeat, please? I missed that, I guess.
Yeah, I think a few people are just asking, we've got POSPac Complete licenses. How does that tie into POSPac Assure? Does it tie in?
Yeah, okay, got that. Well, those are indeed like different products, right? So POSPac Complete is the desktop version that's installed on your machine. You would have a separate license, which is not connected to POSPac Assure. POSPac Assure, as I said, is a different product. You will have to sign up on the subscription plan, or you sign up on the pay permission basis. And yeah, it's definitely disconnected to the POSPac Complete desktop installation, except of that the engine is obviously kind of the same, right?
Yeah, wherever POSPacs run, whichever platform it is on, you're taking advantage of the latest and greatest navigation engine. Is there a file limit or a time limit per mission?
Nope, there's not.
Nice and easy, that one. What else have we got? Let's look. There was a few questions about changing datums and playing with offsets. I think the answer here is in short is no. The idea of POSPac Assure was to keep it as simple as possible. That time to value,
Right.
going from importing your data to creating an SBET. If you're needing to adjust datums, if you're needing to go and really dig into your lever arm errors, your GAMS errors, whatever they might be, then you need to be in the full desktop version. You need to be in POSPac Complete to start taking advantage of those extra features that those things provide.
Yeah, and that basically also adds to the previous question and answer as well. So POSPac Complete obviously gives you more flexibility and more options to change certain settings. And we wanted to keep POSPac Assure easy. But of course, if we see the demand that the frame handling is required going forward, then there are options to do that going forward. It really depends on the user requirements, and you're defining them. And I think at this point, we're going to end the webinar. We hit the 60 minutes margin now. And as we said, we'll get in touch with you for all other open questions that you entered here in the Q&A section. And yeah, thank you very much for your participation today. Please do not hesitate to ask any question or reach out to our customer support team, to Nick or to myself. Try POSPac Assure, give us your feedback, and that will hopefully also trigger future improvements going forward. So I hope to see you again in one of the future webinars. Thanks again, and take care. Bye-bye.
Thank you.